Hey class, good afternoon. Today's October 2nd, and today we're going to be working on linear functions. So I'm sharing my screen with you now. So today we're going to cover linear equations, the slope part. We've been working on linear equations for a bit. The MyMathLab doesn't have a whole bunch on linear equations that I want to cover. So we're going to be working out of the additional textbook. And that again, that additional textbook is a PDF that you can download from the website. You can get it right here on the homepage, the additional textbook. So just click there and download it. And it's also right here on today's note. Okay, we're in section 1.3 of this book. So if you could open up that PDF, so download the PDF and then open the book to page section 1.3. And it's, sorry, I was looking at the homework a moment ago, and it's talking about slope. So here we got points on a line that are not really linear, and then we can make a line between these 2 points to establish an overall slope. Okay, and again, the slope is that change in y over the change in x, right? Or a slope could be like this slope right here, this handicap ramp. They're showing over 12 feet. It goes up 1 foot. So we saw a little bit of that with our trigonometry. So construction laws, and sorry, just looking at the different problems, I was scrolling back, but just to give you an idea of slope and what it is. So here, the grade or slope is given by 1/12. So delta y over delta x is 1/12. It goes up 1 foot in the rise over 12 feet in the length, which is what we're showing here. Okay, it says, what is the slope of such a ramp? Well, if you take solution, 1 divided by 12 is 0.083, or it's an 8.3% grade. Some of you guys live in maybe North Carolina or something where you have mountains with a 15% grade. This has an 8.3% grade, or yeah, 8.3%. They would call it 8.3. Yeah, 8.3% grade. Yeah, percent grade is what they say as you're driving through the mountains. Okay, so we're talking about section 1.3, and we're talking about lines and horizontal lines and vertical lines and lines. So here we got angles with a positive slope. I actually don't want to cover it just the way they did. I want to, so here are some, I'll scroll back up to the beginning of the chapter and we'll go through it, but here we got lines of different slopes. So here in figure 1 on page 95 of the textbook, we have lines with different slopes. So y equal x, a 45-degree line, has a slope of 1, and there's a point on that line, 1, 1. Go over 1, up 1, 2, 2's on that line, 3, 3, 4, 4, 5, 5 is on that line. Now, if we increase the slope, now we have a slope, higher angle, right? This 45-degree line, which is this y equal x, right? Because if x equal 1, y equal 1. So we go up 1 and over 1, up 1 and over 1, which is why 1, right? We went through 0, 0. We went up 1 and over 1. That was a 45-degree line. Then we go up 1 and another 1. That means plus 1 in the x and plus 1 in the y. We're at the point 2, 2. And we're at the point 2, 2. I just want to put a note on my here, right? So we're at the point 2, 2. And then the point 3, 3, and the point 4, 4 is on the line, and the point 5, 5, right? So this is the line y is equal to x. No matter what you put in for x, y is equal to it. And that point 5, comma 5 is on that line. The slope is y, remember we have our equation of our lines, y equal mx plus b. right? That's our general equation of a line that we've been working on. Well, our b here, we go right through 0, 0. So in this case, right, when x equals 0, y is equal to 0, by the definition what they gave us, y equals x. So when x equals 0, y equals 0, that means b is 0. It goes right through 0, 0, goes right through the origin. So now we're just left with this equation y equal mx. And they told us that it's equal to, so the multiplier in front of the x is the slope. Well, what is our equation? Our slope is 1. This is y equal x, right? This is, if m equals 1, y equals x. Okay, so our slope is 1. Then we have this line here, y equals 2x, so the slope is 2. So if x is 2 here, then y is 4. So if we come over here, x equal 2, 2 comma 4 should be on this line, right? Y equals 2x. So if x is 2, 1, 2. And then we got to go up to point number 4. And that should be on that line 2, right? Y equal 2x. If I put x equal 2 in, 1, 2, y equals 4. And then if we have something like y equal 3x, what do we have? Can we get to 6? Yeah, we could get there. So in this one, y equals 3x, the slope is 3, up 3 and over 1. So if we say y is 2, or I'm sorry, x is 2, 2 times 3 is 6. So if we go up 2.6 is right here, which would have been 6 on that equation over here. So as we increase the slope, we're increasing the angle. And then eventually we increase it to a vertical slope. So eventually we increase our slope 3, 4, 5, 6, 7, 8, 9, 10. We go up 10, you know, when we go x equals 1, y equals 10. So we're, you know, really high with a slope equal 10. Let's actually draw that one real quick, right? So on the line here, x equals 1, 5, 6, 7, 8, 9, 10 is about here. So we're going to have a line that goes through the origin, through 0, 0, up to 10, and then going up even higher than these other slopes. Actually, it's probably going, anyway, it's got a more steep up slope in 11 and 12, and then eventually you can't even really see it when you get to a slope of like 20. Then you start changing the scale, so that's what Excel does. It starts changing the scale so it looks like a slope, but the thing's really going straight up and down, which is what happened with the Excel if you've done it. So we're going to wait on perpendicular lines. We're going to, Monday we'll talk about perpendicular lines. We should have plenty of time to talk about Excel, and then I've extended the homework until next Thursday. Okay, so we're going to add a little bit more homework here dealing with slopes. So you make sure you understand the fundamental slopes. Last time you did distance formula and midpoint. If there's any questions, email me, what have you. But right now we're talking about slope. Okay, so positive slope, and then over here they're showing negative slopes where it's sloping downward. And for everything we've been doing so far, y equals mx, so we have just one line, one slope. Then here's no slope. There's no change in height for a change in x. All we're doing is changing x. So when y is a constant, whatever it is, if y equals 0 or y equal 1 or 2 or 3 or 4, whatever, these horizontal lines have no slope. There's no change in height. It's just a horizontal line that has no change in height, right? So if we, I'm going to switch over to my Elmo here for a moment. We were just talking about horizontal lines, right? And what was the equation for slope? Y, the slope equals delta y, the change in y over change in x between 2 points. Well, if y2 minus y1, right, if it's the same y value, say this is the line, this is x equal 6, and this is x equal 9, and this is y equals 3. So we have the point 6 comma 3, and we have the point 9 comma 3. Right, so we're going to calculate the change in the slope on this. Well, The slope, the y values are the second coordinate. So that's 3 minus, sorry, over x2 minus x1. So our y value is 3, 3. So 3 minus 3 is 0 over 9 minus 6. So we get a 0 divided by 3. Okay, so 0 divided by 3 is 0. So I have m equals 0. So a slope that is 0 is a horizontal line, right? And then we have slope of 1, 45-degree line, slope of 2, a little bit higher line, slope of 3. And we're going to show the tangent, you know, at some point we've shown the tangent of theta equals the slope. So you could, if you know the angle, you can get the slope, and if you know the slope, you can get the angle. So at 0 degrees, I mean, what was the angle of 0 degrees, right? If slope, if m is 0, theta equals the tangent inverse of m. So we just said that the slope was 0 for this horizontal line. So we're just going to show the number of degrees of elevation. So theta equals the tan minus 1 of 0. And what do you get? So go to your calculator. Go to your calculator and figure out what is the inverse tangent of 0. Calculator or cell phone. 0, second function, or inverse, I'm sorry, or shift, tangent of that one. Inverse tangent of 0 is 0. So theta equals 0 degrees, right? This is our horizontal line, right? When we said that's, when we did our stuff with vectors, this is a line of 0 degrees, right? And if we did this one more time for, let's say, a tangent of 1, a line that was a 45-degree line, right? If this is 45 degrees, tangent of theta equals m. What is the tangent of a 45-degree line? That's my m. Okay, so for a 45-degree line, tangent, since I know this time, I know the angle, 45 degrees, tangent is 1. So on a 45-degree line, my slope is 1. And alternatively, if we said the slope is 1, but we don't know tangent of theta, we could say theta equals, what's the inverse tangent of the slope? Again, in this case, the slope is 1. What's the inverse, or the second function, tangent? Gives me back to my 45-degree line. So at 45 degrees, m equals 1. What we were just talking about, slope of 2 a minute ago. So 2, shift, tangent. So a slope of 2 is a 63-degree line. So when slope is 2, we got a 63-degree line. How about 3? 3, inverse tangent, is a 71-degree line. Right, so m equals 3, that's a 71-degree elevation. Right, and what we said, right, when we get to something like 20, the inverse tangent of 20 is an 87-degree line. So at some point, you know, it just keeps going up and up and up and up and up until we get to infinity, which is the other one. So we got a slope of 0. When the change in y is 0, we have a horizontal. When the change in y is 0, there's no change in rise. It's all just, it's the same. It's a horizontal line. It has a 0 slope. When we have the opposite to be true, we have a vertical line. Our slope is y2 minus y1 over x2 minus x1. Well, right, we were talking about a 20-degree, I'm sorry, slope of 20 was a 20 degrees. Inverse tangent is 87-degree line. Right, as I get to 89.9 degrees, what's the tangent of that? Nope. What's the tangent, right? The tangent of the angle theta equals the slope. So let's get the number real high, 89.99 degrees. What's the tangent of that? 55,729. So if I got an 89.99 degree angle, my slope is 5,730, 5730. And if I add more 0.9s on there, 89.999 tangent, my slope went to 57,295, which is pretty near, just added another 0 and we added another 9. Add another 9, that's probably gonna do the same thing. And it's gonna keep going toward infinity as we get closer and closer to 90 degrees. Because 90 degrees tangent is undefined. It's like dividing by 0, which is exactly what we're gonna show here. So we have an infinite slope. They call it an infinite slope when my angle is 90 degrees. I've got an infinite slope. M equals infinity at a 90 degree line, which we're going to show here, right? So y2 minus y1 over x2 minus x1. When we have a 90 degree line, when there's no change in x, it's all straight up and down, right? So we have 2 points like this, 0, 0, and x equals 0 and y equals whatever, 10, right? So y2 minus y1, 10 minus 0, m equals 10 minus 0 over x2, which is 0, minus x1, which is 0. So I have 10 divided by 0. 10 divided by 0 equals error. M equals error. What the heck do I do now? It's an infinite slope. They really should say m equals infinity, but they don't. They call it an error. They say, oh, you can't have you can, it's just an infinite slope. And usually what we do is we cap it, but that's, we're gonna cap it at R. Sorry, more on that later. So what's cool about a circle does a great job of showing the slope. So at some point we've got a horizontal slope, and then we've got a tangent. A tangent line is a line that touches the circle in one spot, right? And these are arrows pointing. So the tangent line here, the tangent line here, right? We got a negative slope. We go back to a 0 slope. We've got a positive oriented slope. Up and to the right is a positive slope. Increasingly positive, increasingly positive, increasingly positive, increasingly positive. And then we have another vertical line, like over here. And then we got a decreasing slope and a decreasing slope. And then eventually this thing comes around. And then we've got another horizontal line. So at these points, at the horizontal lines, in this case, these are tangents. Sorry. It's very similar to what we were just talking about, where we've got slopes that vary from, these are perpendiculars, which are tangents. But the idea is important for slope. The slope of the tangent line is what we're going to say in MA 112, right? And how that slope changes on a surface, which is the next section, parabolas and quadratics. Notice how the slope changes over a parabola is y equal x squared. Well, here's an upside down one, half a circle. And the slope changes from a negative oriented slope to a 0 slope to a positive slope. So when you're on a parabola, your slope is always changing, and it has 2 directions. That's second degree equation. Our first degree equation has 1 direction, has 1 slope, and it's a constant. We go into second degree equations, we're gonna have 2 directions of the slope, and it had to change from one place to another. All right, that's over your head, and that's not what I meant to do. Okay, slope. So we have horizontal lines, and we have vertical lines. Horizontal lines have a m equals 0, a slope of 0. The slope is 0. And vertical lines have an infinite slope. Okay. And then there's two more, right? We got a positive oriented slope, which is up and to the right. And then we got a negative oriented slope, which is up and to the left, up and to the left. Up and to the right makes a positive slope. Straight up is an infinite slope. Up and to the left is a negative slope. It's sloping downward. This is sloping upward. That's sloping downward. And then the horizontal slope is there's no slope at all. The y value over here equals the y value over here. Okay. So let's go back to the text. All right, so we're talking about linear functions. Determine the slope of a line given 2 points on the line. So we know 2 points, we can calculate the slope like I just did. M equals y2 minus y1 over x2 minus x1. Solve applied problems involving the slope or average rate of change. The rate of change of data, how is like the price changing with time? We can linearize that data set and then use that information across using that line or line of best fit. Find the slope and intercept of a line given the form y equal mx plus b, or some function of x equals mx plus b. Graph a linear equation using the slope and intercept. So if they give you m and b, right, we can quickly graph that. We know where the intercept is, we know what the slope is. Okay. Linear functions, so here's a negative oriented slope, right? Here's a -1 slope. Here's a slope, here's no slope. And then here's that parabola or something with a second degree that has two different, actually has a whole bunch of slopes. The slope at one point and then it's coming down and it comes down and it has a horizontal slope across the bottom and then it starts increasing in value. This is going to be very important in MA 112 is the slope of the tangent line is the derivative of the function. That's how's that function's y changing with x, right? And that's what we're doing with slope. The change in y is the change in x, or the change in y over the change in x is the slope. And that slope is constant for a line. It is not constant for a non-line, i.e. a non-linear function. In a non-linear function, the slope is always changing. In a linear function, the slope always stays the same. So it's easy to predict points on the line because they're just, go that way, increase my x, solve for y, increase my x, solve for y, and it's linear. Okay, so linear functions, y equal mx plus b, we can solve for the slope, y2 minus y1 over x2 minus x1, and they put them in our form. Been saying this since the first one here, but y equal mx plus b. So here our slope is 1/5 and our y-intercept is b. I'm sorry, our y-intercept b is 2. Hence this point right here, 0, 2. It's the y value when x is 0 is the y-intercept, right? So I put a 0 here for x. 0 times 1/5 is 0. 0 plus 2 is 2, and so my y value is 2 when my x value was 0. That is my y-intercept. And the 1/5 is the slope. So you can think of it as I go up 1 and over 5, so you can get to your next point. We're going to go up 1, so add 1 to 2 gives you your other x value, and then we're going to go over 5, so add 5 to your x value to get your next x value, right? Our slope was what? 1/5. In this case, it makes sense not to reduce the fraction to say 0.2, but it's better to just say, okay, well, I'm going to rise up 1 and go over 5. Well, if I know this point 0, 2, I rise up 1. So that means my y value went from 0. I'm sorry. My y value went from 2 to 3. Right, 2 plus 1 is 3, and then my x value was 0 originally, and I'm going to add 5 to it, to get my other x value. So fractional slopes are actually kind of nice because when you think rise and run, you can calculate the next point immediately when you know the slope. If not, if you're going to use the fractional form, always make your x, change in x 1, and then if your slope's like 0.2, so if I make my change in x 1, then I went up 0.2 in the y. So on the point, right? So if x is 1, I went over 1. The next point at 1 is 2.2 because I went up 0.2 in the y, right? If you made this 0.2 times x plus b, right? I went up this. If the slope is y, delta y over delta x, if delta x is 1, delta y here is 0.2. 1 over 0.2 is 0.2, which is the slope 1/5. And if I wanted to just move over x1, then I'm going to add 0.2 to the y value. So the y value will be 2.2, and I'll have the 0.1 comma 1.2. And then 2 comma 2.4, and 3 comma 3.6, and 4 comma 4.8, and 5 comma 3. Clear. Okay, mouse. Okay, so we got these functions. We got an increasing function or a positive slope, right? In this case, we got the points 4, 4, and 1, 1 that are on that line, and -3, -3, that's your 45-degree slope, or 45-degree slope that goes through 0, 0. 45-degree slope, right? That was that m equals 1. This is the equation y equal x, right? If we put it in y equal mx plus b, m is 1. Right? We're talking about y equals x for a moment. The original equation equals y equal mx plus b. B is 0 because if x is 0 here, y is 0. Right? From y equal x. If x is 0, y is 0. And then if y, right, the multiplier in front of this is m. The multiplier is 1, which is 1 here. So that's why the slope is equal to 1, and the y-intercept b in this case is 0 for this one right here. Right, the y-intercept, that's where the x is 0. So it goes right through the origin and the slope of 1. Clear. Okay. Then we have the vertical line. Please read over this. The linear function f of x, mx plus b. Please read this. Take a few moments to look at this and graph this. Here we've got these points, 10, 50, 20, 100, 30, 150. And then, so we can get this linear function of data. So please, the increments 10 in the x, and then your y value is increased by 50 each time. It's a constant rate of change. So please read this section, page 93 here. All right, we talked about slope, rise over run. Okay, graph the function and determine its slope. You don't even need to graph this function if you look at it. Graph the function f of x equals -2/3 x plus 1. So we're going to graph this, right? F of x equals -2/3 x plus 1. All right, where do I graph, Mr. Lair? How do I do this? Okay. What do we know? We know, right, since the equation is mx plus b, there's a multiplier times x plus b, some constant. We're in this linear type of a function. In this case, I know my slope is negative, which means it's going to be kind of down and or up and to the left or down and to the right versus up and to the right. And then our intercept here is 1. So we got a negative slope and an intercept of 1. So that means when x is 0, y is 1. So we have this point, 0, 1. And in this case, they're saying, well, I could do it that way. You could solve these problems a lot of ways. In this case, they're going to say, well, if I'm graphing it, it's in the xy coordinate system. So if I plug in some value of x, I can obtain the value of y. So they are not quite so arbitrarily, but they picked the value. All right, let's try x equal to 3, because it's going to make the multiplier easier. If x is 3, I got -2 plus 1. So x is 3, I got -2 plus 1. -2 plus 1 is -1. So now I have the coordinate pair x equal 3. And f of x, I evaluated that function with the 3. When I evaluated it, I got -1. So this is -1. So I got the point 3, x equal 3, 1, 2, 3, and y equal -1. So they plotted that. They did not plot the y-intercept. They started with some arbitrary points. So there's alternative ways of doing this. Then the second easy point they used was 9. So if we plug in 9, because of this third one or 2/3 power, it makes the fraction cross out. So -2/3 of 9 is 6. I'm sorry. So I got -2/3. We're plugging in 9. Right, this is my x value, so I'm just plugging it right in. -2/3 times 9. 9 times 2 is 18. 18 divided by 3 is 6, and then we've got that negative sign there, so it's -6. -6 plus 1 is -5. So we have the coordinate pair 9, -5. You should be working this out on your own on paper so that you understand how to solve these problems. Okay, so now we got these 2 points. They went back and reproved it. You were just supposed to graph it and determine the slope. Okay, so they found 2 points on the curve, and now they're going to go back and calculate the slope between these 2 points. So they have their 2 points. They have their x values and y values. Their x values they chose, x2 was 9, x1 was 3. So as we plug in the solve for the slope, the slope is going to be the same between any 2 points on the graph. Doesn't matter which one you call 1 and 2, just any 2 points on the curve. Any 2 points on the line are going to give you the same slope. So it doesn't even matter which one you call 1 and 2, you just have to keep the x and y paired order the same. Okay, so they plugged in x, y, right? The second point was this one, this is point 2. x2 is 9, y2 is -5. So we get the -5 and the 9. And remember how the formula works, minus, and then minus what? Minus x1 and y1. Well, x1 is 3, so 9 minus 3, and y1 is -1. So I get -5 minus -1. Okay, so -5 minus -1, that's -5 plus 1. -5 plus 1, -5 plus 1 is -4. 9 minus 3 is 6. So we get the slope -2/3. Hey, that looks just like what they told us. Right? The multiplier, when we have y equal mx plus b, that multiplier times x is the slope. And we calculate it by using that function. And the intercept is when x equals 0, that's the value of y. So kind of, we always know that first point. And if we know the slope, we can go down 2 and over 3. Right? So we could go down 1, 2, and over 1, 2, 3. And actually obtain that at that next point just by knowing the slope and the intercept, right? Down 2 and over 3. It's a negative slope. Rather than up 2 and over 3, we go down 2 and then over 3. That's that negative oriented slope. Right, I went down 2 from our original point, which was what, 0, 1. I subtract 2, 1, 2, and then I go over 3. 1, 2, 3. So that same point that they calculate, (3, -1, right? The original point was 1. We went down to 1. 1 minus 1 is 0. Minus another 1 is -1. That's down 2. And then plus 3. 1, 2, 0 plus 3 is 3. So that's how we get these, the coordinate. Down 2, 1, 2, over 3, 1, 2, 3, down 2. So my x went down. Sorry, I rise down 2, and then I run 3. Okay, clear. All right. So we talked about different slopes, different values of m, horizontal lines and vertical lines. Horizontal lines have a slope of 0. There is no change in y. Vertical lines have what's called an infinite slope or undefined. Reread this section here, horizontal and vertical lines. Horizontal slope, no change in y. Vertical slope, no change in x. Can't divide by 0. It's infinite. Remember, as we went 89.99, 80.9999, we kept increasing by a factor of 10 in the slope as we add another decimal place of accuracy. Okay, graph each linear equation and determine its slope. So I hate when they keep giving us all the exceptions first. Okay, so here we have x equal -2. So graph the line x equal -2. There's no change in x. It's all y values. I do not have a slope. So this is this infinite slope. And then over here, the second one, y equals 5/2 is a horizontal line. So I have a slope of 0. All right, in this case, the slope is 0. And over here, it tells us our slope is undefined. And in this case, we have x equals -2. It doesn't matter what the value of y is. X is always -2. And when we calculate our slope, delta y over delta x is 0, no matter which y we cover. So we have this infinite slope. Okay, you can work through that problem on your own, I know. Applications of the slope. So grade is this change in y over change in x. It's as a percentage. The maximum slope of a track is, it's 20%. So read this application of slope. Slope has many real world. I'm gonna let you read that. We got a treadmill, it's got an application of a slope. We got this bobsled track that's got a slope. We talked about the disabled slope here for a disabled ramp. 12% grade or slope. So the fractional value was 0.083. So multiply that times 100, gives you an 8.3% grade. Grade is that percentage, and it's a percentage. Multiply it by 100. Take the fraction, take the slope, divide out get the numerical value of 1 divided by 12, and then multiply by 100 to get the percentage. Average rates of change, where we pick points on the line and draw a line of best fit through it. So get out your straight edge, put your straight edge on your machine here, right? And I'm going to try to draw a line with my straight edge here. Oh, I got my touch screen going. Well, whatever. But there might be a line that fits through there that you can now read down and say, okay, here's an XY point, and say, here's another XY point, and what is the average change in Y over a change in X? This is called like a line of best fit. So you make your best fit through your points the best you can, and then you find points that cross the grid lines that are easy to read off, like I circled here where my line crosses the grid hair. Not a data point itself, but someplace where it crosses the grid hairs that you can actually read the X coordinate up to the graph and then over and read the Y value, right? We're gonna read, right? For this point here, we read down, we get the X value, and then back up and then over to get the Y value, right? And that gives us our point, X2, Y2. X2, sorry, that's X2, Y2. I'm trying to hurry because it's already after 2. Clear. So then they pick 2 points. The Y values are percentages. So they've got 2 points that they picked on the graph that they wanted to calculate it over. Y2 was 18, Y1 was 6.5. So this is the Y2 minus Y1. X2 is 2008. X1 is 1985. So we have a 23-year time period. And we see that there's a 0.5% change in obesity of children from 12 to 19 in America per year. We're increasing by 0.5% per year. So that's not too good. And you extrapolate that all the way out to 2020, another 12 years, we could do that. We could extrapolate that. Once we know this equation, now we can plug in X, right? Once we know this equation, once we know the slope, Y equal mx plus b, we can plug in 20 and estimate the new value, Y, whatever it's going to be, but we can be assured, since the slope is going that way, that as we increase X, the Y value is going to increase. And then if we know this is the year 2020, whatever that associated Y is, so let's say it's going to be about 25, maybe 30% by the time we're here today. If that trend continued, that would be a true statement. And I don't know how the trend is currently going. All right, so that was average rates of change. You should definitely read our snowboard ones. So in 2005, we sold 336,000 units. And it looks like we're decreasing. In 2009, we only sold 287,000 units. So we have a negative slope. Our X value increased in time. That's a positive. But our Y value decreased. So we have a negative oriented slope. So our sales are declining. And the same thing is once we calculate that slope between the 2 points, in this case, what do we have here? So delta Y over delta X is 12,361 less boards per year, right? Because this is a rate. The change in Y is the number of units sold. The change in X is a year. So as I change my number of units divided by number of years, so I'm down 12,361 units per year. And then again, you can project that out forward to 2020 and solve for X and Y. Okay, slope and intercept. We've done this, Y equal mx plus b. Okay, example 6. Find the slope and intercept of the line with the equation y equal mx plus b. Find what the slope. The slope is the multiplier in front of the x, so I got a negative slope, so I got a decreasing value. And I also have a negative b value for the first time. Most of them have been positive. In this case, our b value is negative. So we look over at the drawing over here, right? We have 0, negative 3.8 as our first value. And then we have a declining slope. It's a slope, right? It's a negative oriented slope. Kind of like this, the snowboard sales were decreasing per year for whatever that was. I don't know if that's a true statement overall. Probably not. Okay, find the slope and intercept of the line given this. So remember, we solved y equal mx plus b. So we have to get the y by itself, put everything else on the right-hand side of the equation. So they walk you through that, and then solve for y equal mx plus b. Our slope is the 1/2. Our b is the negative 7.6. Positive slope up and to the right. Definitely go over that one. Clear. Mouse. Okay, rise and run. Estimating height, rise and run, change in y over change in x. And this is where leaving slope as a fraction is beneficial, because then you can get to the next point real easy if you know the slope. If you make it a numeric, like 0.7, assume the change in x is 1, and then the change in y is 0.7. So whatever it was, if it's a positive slope, whatever the previous value of y is going to be plus 0.7. As we go over x, x goes up 1, and y is going to go up 0.7. Or if the slope is 3 over 1, we're going to go up 1 in the x, and then we're going to go up 3 in the y because the slope is 3. So you can always divide by 1 to get the change in x. So that's why x value is going to step over to the next one, and what's the slope doing is going to affect the y value from the previous y value to the next as we go 1 value in the x. All right, visualizing the graphs. Here we got a negative oriented slope with a y-intercept of -4. Looks like that might be number 3 there. Number B here, we have a horizontal slope, I'm sorry, a vertical line has no slope. And so we have a constant x equals -10. And that'll be all the values of y. So number 9 is probably B. Here we got a negative oriented slope, and the y-intercept is -2. Here's a negative oriented slope with the y-intercept is -2. I don't see any other ones that have that same intercept. Number D, we have a positive oriented slope, and the y-intercept looks a little bit bigger than 2. A little bit bigger than 2, it's not 3.5. A positive oriented slope, it could be this one. I don't know if we divide this out. 5 over 15 is 3, so that's probably not it. 7/2. Okay, maybe that is 3.5. I don't know. Is that a slope of 1? Looks like a smaller than 1 slope. Anyway, here's the y-intercept is what, 1, 2, 3.5. So there's their 3.5. X equals 0, 3.5. We got a positive oriented slope. So that number 10 is probably I. Here we got a horizontal slope. So we have no change in y. So I have a slope of 0. And my y value is constant. So it looks like a y value of -1, 2, 3. Y equal -3, number 7. Here we got a negative slope with an intercept of 0. That could be this one right here. We have a negative, right? If we divide the y equal mx plus b, so I got -4/3 x is my slope. That's a negative. So if we went up 1, 2, 3, 4, does that go over 1, 2, 3? It does. So G is this number, this one here, because it has a 0 slope or a 0 intercept. And then we had to get it, the y by itself, to determine the m value. Okay, and then I provided you homework problems that I want you to do. I'd like you to do these problems 11, 13, 15, 17, 21, 33, 35, 37, 49, 53, 55. 11 through 13, I've got a 2:30 appointment, so I have to scooch number 11. So here we're given 2 points, and we're asking you to find the slope. So find the slope between 2 points. That's 11 through 17 and 21. Okay, so that's no big deal. 31 through 33, you're given these points, determine the slope. Determine the slope. So the slope is the multiplier times the y value. I'm sorry, y equal mx plus b. So it's the x value. So like number 32, the slope is -2/5. In number 31, the slope is 1.3. In number 33, x equals -2. I've got an infinite slope. Okay, and then what do we got? 49, 53, 55. 49, 53, 55, you're supposed to find the slope and the intercept. So you get your y equal mx plus b. So you should be able to crank right through that homework. You guys have a great weekend. We'll see you Monday. We will go to the next section of this, which is the parallel and perpendicular lines. And then we'll be able to get into, here's our parallel lines and our perpendicular lines. So we will get to that section on Monday, and then we'll get into the graphing, and then we could, probably be ready to do that first homework that I assigned you. Sorry for getting too aggressive. Now you get some problems you can work, and then you get some problems you can work out, and then you can get your homework done nicely and efficiently. All right, sorry I'm a little late. I am posting this lecture right now, and I will see you guys on Monday. Have a safe weekend.